Question 10, part B. It says let gx equal x to the power of k, where k is a positive integer. Now in part 1 it says find the first three derivatives of gx. So g dash of x. Now this is just a polynomial, so we would bring the power down. It will be x as a coefficient, sorry, k as the coefficient, and then x, and we reduce the power by 1, so k minus 1. Okay, now the second derivative, we would bring the power down again and multiply it by whatever's already at the front. So it'll be k now multiplied by k minus 1 x, and we reduce the power by 1, so it's going to be k minus 2. And our third derivative, once again, we bring this power down, so it'll be k at the front of k minus 1 at the front of k minus 2 x, and we reduce the power by 1, which will be to the power of k minus 3. Okay, so we have our first three derivatives. Now for part 2, I'm going to write part 2 up. Okay, here we go. It says given that the 19th derivative is equal to k factorial over k minus p factorial, x to the power of k minus 19, find what this value of p is. Okay, so this looks like a complicated question, but it's actually not too bad. Let's have a quick look at this one, and I'll refer to this. We had the third derivative, and what we had as coefficient was k minus 1, k minus 2. Now I could write this as k minus 1, k minus 2, k minus 3, and then so on, so on. So I'm actually going to put a factorial after the k minus 3. And if I divide that by k minus 3 factorial as well, notice that all of these would cancel out. The k minus 3 onwards, k minus 3 onwards. But the reason why I want to write it like this is notice that this top line is actually just k factorial. This is just k times all the ones below it. That's why I started at k minus 3 factorial, but I could have actually started all of this as just k factorial over k minus 3 factorial. So the key here is that k factorial over k minus 3 factorial is just this bit. So this was the third derivative, and notice that our value here was 3. We're actually going to get a very similar thing here. If we had k factorial over k minus 19 factorial, and then x to the power of k minus 19, this will actually be our 19th derivative. Notice that our coefficient here would just be k times k minus 1 times k minus 2 all the way down to k minus 18, and that's what this pattern is here. This was 3, it went to 2. This was the second derivative, went to 1, so it's 1 less. It goes to 1 less as the coefficient. So this should go to all the way down to k minus 18, so therefore on the bottom we'd have k minus 19. I probably could have explained that a little bit better, but I just want us to really realize that this k factorial over k minus 3 factorial will create our answer here. So if it was the third derivative, this would be k minus 3. So if this is the 19th derivative, this is k minus 19. So we can just write hence p will be equal to 19. Okay, that's the answer to part